Greetings, everybody. So I started the recording, and the purpose of this session is to help you with your linear regression assignment, with your R assignment. So I'm going to go ahead. I started the recording. Let's go ahead and get started. I'm going to share my screen. All right, minimize this. So here it is, the RStudio. Hopefully most of you already installed it and started playing around with RStudio. For the purpose of today's demo, I'm going to use the electric bill dataset, and that dataset tracks the energy consumption and the number of cooling degree days, the number of heating degree days per month. And basically, the whole idea is to predict the energy consumption and based on a bill. Okay, so first of all, to get started, what we need to do is I open the RStudio. Now I have to set the working directory. There is more than one way to do this. So the way I usually do it, I go to Session, Set Working Directory, and I'm going to go ahead and I'm going to choose the directory. And on my drive, I have a folder that I created where I track the data sets. So there is more than one way to do this, but that's my preferred way. Okay, here it is. So I set the folder, dataset, and I'm going to select this folder. And this is my working directory. Behind the scene, R runs this command for me. So this is my folder. For you, it's going to be a different location, right, on your hard drive. So now what I'm going to do is I'm going to load the file. Right here, I already have the command written, but I'm going to show you how to do it, of course, you can write this command, but probably for you guys, the easiest way to do this is do this. Tools, import dataset from local file, right? Now make sure that you have the latest RStudio version. In the latest version, it's from local file, not from text file. Okay, so now what I'm going to do is I'm going to find my data set. Now notice that it's opening it up in my working directory that I said, right? So I go electric bill, I go open. Now what's happening here is that here is a data preview. Here for some reason it does not like my default headings. So it's trying to rename it V1, V2, V3. So when that happens, you want to check yes. Okay? Sometimes it may not like that the heading names are too long, perhaps. But if that happens, just click yes. Here, it's telling me that the values are delimited by comma. So this is the preview of what is in the data file. And here is the preview of how my data frame is going to look like. So I'm going to go ahead and I'm going to click import. And what R will do, it will run this command for me. View electric bill. And the view command is going to show me a preview of how my data looks like. Right, so here are all my variables. And this is the energy consumption that I want to predict or estimate. And here is the total charges. And it's showing me here if my heat pump is new, if my meter is new, and how many people live in a household. And this is the cooling degree days per month. So I believe the way it's defined is that it takes the average temperature during the day, and it takes the difference between the actual average and 65 degrees. That's a cooling degree day and a heating degree day, of course. So heating degree days is a number of degrees. The average daily temperature was below 65. Okay, so this is the average, and well, this is per month, of course. Now here it is. It's a bill amount, month, year, and the observation number. Now, what I want you guys to notice here, observation number is a unique identifier. It's just for the purpose of identifying a record. This variable does not play critical importance when you predict the price, right? When you predict the consumption, rather. So what we will do as part of our data pre-processing step, we are going to remove this column. We're going to remove it because this is basically unique identifier, right? So here it's showing me that this dataset is small. I have only 120 rows. So we're going to go back. Here is a script that I wrote. So now what you can also do is you can run the summary command. And now if you recall, the summary command shows the descriptive statistics for your data. Here, for some reason, it loaded the year as a number instead of the factor. But anyway, it loaded the month as a factor. In this case, I have 10 occurrences of April, 10 occurrences of August, 10 occurrences of December. Usually what it does is it picks 6 most dominant values and lists their frequencies. Now, notice that I don't have any missing values in my data. Here, you notice other, what it does is it takes the least frequent values and calculates the total number of occurrences. So here it is. In your paper, you may want to discuss the descriptive statistics, such as minimum, maximum, and variance for all these variables. And you could also do is you can print the number summary, right? You can print the number summary for each variable. Like, for example, I want to print the average temperature. I want to print the average temperature statistics, and so on, and just go run. Oops. Oh, okay. Okay, I'll get an error. I'll have to look into it later. But what we could also do is we can do this right here. It worked, right? So what this command did is it showed me the average. It showed me the average temperature per month. Notice that the months are not ordered by months; they're ordered in alphabetical order. It is possible to order by month, but it's more advanced topics that you're going to learn in later coursework. Now, what you could also do is you can do different plots. But for right now, let's do this. Let's go to the regression. What I'll do is I'm going to remove unique identifiers we discussed. And why are we removing it? Because unique identifier does not really determine the energy consumption, right? So if you see unique identifier, you can just remove it. And in fact, they slow down the method performance, something to keep in mind. So this is what I recommend. I recommend you guys write a script, right? And each time when you log in, you can do file open and then just rerun the script. That way you don't need to rewrite the commands. Now, here it is. Electric bill is my data frame name. Observation number is a variable name. I'm setting it to null, right? So that will delete the variable. I'm going to do this. Okay. Run. It's because I had to put a cursor on a line. I should not be highlighting the line. I accidentally highlighted the B. That's why it did not run. Okay. So what this did, I removed the variable. How do you verify that the variable is removed? I can run my summary command, or I can look here. This is environmental tab, right? I no longer have it. Or I can run the names command. Names. And the names command is going to show me the variable name. Electric bill. I like it, right? I type and it gives me the choices. Here it is. So it's gone. Now what I'm going to do is I'm going to divide my data into the training set and test set. Why do we do that? Because we want to build our model using the training set, and we want to validate our model in the test set. So what does the model do? The purpose is to build sort of like an equation where if I tell you how many people live in a household, how much money I had to pay for the electricity bill or utility bill, and the number of heating and cooling degree days, and if my meter is new, if my heat pump is new, total charges, I should be able to estimate the energy consumption. So if I give you all this information, you should be able to use a model to estimate the energy consumption. That's the whole purpose. So now what we'll do, I'm gonna go back to my script here. Notice I have a command to set seed. So basically, when this method divides the data into a training set and a test set, it uses a random number. It generates a random number. So sometimes I want to rerun my script. I cannot do the work if I'm unable to do the work in one sitting. I want to be able to come back to my work next time, on the next day perhaps, and I want to be able to reproduce the same result, right? So I don't want to be rewriting my part of the paper that I've already written. So I'm gonna run set seed, and the number here, it could be any number. I just picked 1, 2, 3, 4. I hit run. I just hit run, and it's gonna put the command in the console window, right? And it's gonna, in this case, there is no output, right? Because I'm just setting the seed. I'm not printing the output. Here, what I'm doing is I'm defining the index, and I want 70% of my data to be in a training set and 30% in a test set. So what I'll do here is I'm going to do run. Here I'm creating I'm going to create my training set, and notice that what it does is it's going to pick 0.7%. Letter C creates a list. So here index 1 is this. Okay, so I'm going to go ahead and I'm going to run this command, run. So I created my training set and I created my test set. So if I want to see here, see this? So you want to make sure that the number of variables in a test set is the same as the number of variables in a training set, right? And here it's showing me the number of observations in the training set and the number of observations in the test set. So what I'm going to do right now is I'm going to build my model. There is more than one way to do that. The model takes 2 input parameters. First input parameter is a formula, and the second input parameter is a data set. The data that I'm using to build my model on. In this case, it's going to be train.electric bill. Now, the formula is basically specifies what my target is, the variable that I'm predicting, and which variable I'm using as predictors. I could go ahead and define a separate variable called formula, or I can just plug it in right here. This is one way to do this. So now here it is. Right before the tilde, I specify my target variable. After the tilde, I can list all my independent variables. I can make the whole list just by name and delimit them with plus sign, or I can just go ahead and put dot. Dot is a wildcard. It tells me that I want to take my consumption as a dependent variable and the remaining variables as independent variable, right? So what I'm going to do is I'm going to run this right now, and I'm going to store my result in a variable model. Why am I doing it? Because later on, I want to run some analysis. I want to see the results, right? And I don't want to repeat this whole thing, right? So I'm going to store my results in a variable called model. I'm going to hit run now. Okay. So what did it do is it stored the results in a variable called model. To see what's in there are several ways. You can run the summary command, but summary command is not good. It may or may not give me all I need, but let's do that. Okay, so let's look at the output of the summary command. Here, call basically is the command that I ran to produce to build the model. Call is a command that I ran to build the model. Now here, what I see is consumption is my dependent variable or target variable. I use these two words interchangeably. Here is tilde, right? It separates the dependent and independent variables. Wildcard dot means I want to use all of my variables, all of remaining variables to build the model. Here is a data set that I was using. In this case, it's a training data, right? Residual is the difference between an observed value or an actual value and an estimated value. So what it did here, it took the differences between observed value and predicted value, and it gave me the information on the minimum difference, maximum difference between predicted and actual value, and the first and third quartile, and the median. So those are the statistics for the residual. Residual, it's a difference between the actual value, right, and the estimated or predicted value. So here is my model. So you may or may not remember back in high school where you use the graphing calculator to write the equation of the line when you have a bunch of points, right? And you wrote the equation of the line. And the way the line looks like, you have an intercept of the y-axis, and then you have the coefficients. Each coefficient is a slope, right? This is a similar problem. The difference is that here you have multiple independent variables. So instead of line, you actually have a hyperplane where each independent variable is going to have a coefficient. So now, if you look at it here, the first column, those are the coefficients for each of my independent variables. So now let's look at what's happening in here. Total charges, this is a continuous variable. Now remember this, we have continuous variable and we have a discrete variable. Continuous variable have continuous values. There is no set of predefined values, right? So we don't know, we don't have a specific set of values for the total charge. It can be $100, it can be $105, and so on. For the months, we only have 12 months, right? We have a predefined set of values. So this is also called factor. So what this method did is that, note here, for each factor, it created a separate variable, right? August, December, February, January, June, July, and so on. Notice that April is omitted, right? So what it did was it took, I think it may have taken it with the lowest coefficient and omitted it. Yeah, because it picked how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So it picks 11, which it thinks the most significant. Right. So now here, look at this. An intercept, right? What's an intercept? It's basically the value of it's an energy consumption when all other variables are 0, so to speak, right? If all other independent variables are 0, this is your energy consumption, right? So here, basically, what it's saying is that when the month is August, this is the amount we add to the energy consumption. When the month is December, this is what we subtract from the energy consumption. So that's what coefficient basically means, right? So if month is September, this is how much we subtract from the energy consumption. This is how we read. This is how we read the model here, the coefficients. For each value of the independent factor variable, it produces a separate variable called dummy variable. So basically, what's nice is that you don't need to do any extra pre-processing before running the method. You don't need to break down the variables into a set of dummy variables, which is nice. Here, this is a bill amount, so this is a coefficient. So it means that for every dollar increase in bill amount, the energy consumption will increase by this much. The coefficient shows an increase in the energy consumption for each dollar increase in a bill, assuming that the remaining variables stay constant. Now here, apparently, what it did was it determined the called multicollinearity. So what it did was it eliminated these three variables because they are collinear with other variables that you already have. such as here. See this? It determines the collinearity between the variables. So basically, that's why it eliminated them. See this NA? It means it automatically eliminated these three variables. And here it is the family members. So this shows me how much each family member adds to energy consumption. Okay, so the more members in a family, of course, the more energy is consumed, right? So now here is the bill amount, and here I'm showing the new heat pump and new heat pump too. So that's assuming that the house has two heat pumps. So now here, notice that dot, right? 3 dots. So this column, the p-values, tell how significant the coefficient is. Apparently, the bill amount is very significant, the total charges is significant, and whether you have a new meter, this apparently happens to be significant. Here, it just shows you, it's sort of kind of like a legend. It shows you that its significant coefficient is between 0 and 0.001. It means the variable is the most significant, right? So this dot basically shows you the significance. And then the R-squared statistics, it basically shows you the differences between the actual and the predicted values. So the lower the R-squared, the more accurate is the prediction. So basically here are the statistics, right? And what you could also do is you could display the fitted values and you can display the residual. So for each observation, this right here, this comment is going to show you the difference between actual and predicted value. Right? But again, this is going to be the training set, right? So here, fitted is going to show you the predicted values, right? Predicted energy consumption. And this is I can just display only the coefficient. So this is very convenient because if you want to write what the model is, right? You can just do this and then you can do, for instance, this intercept, right? Plus year multiplied by this number plus here it's going to be if the month is August, this is what we're going to add. If the month is December, this is what we're going to subtract, right? So if the month is not December, then the coefficient for this variable is going to be 0, of course, because month is not December. If the month is February, this is what we subtract. If the month is not February, then this part is 0, right? This is how you read the categorical variable. This is if your heat pump is new, then this is how much you will add, right? If the second heat pump is new, this is how much it would consume extra energy. And if the heat pump 1 is new, this is how much less energy you consume. Every family member will consume extra energy, right? Okay, so now what we're gonna do is I'm gonna show you how to plot. Okay, so what we're gonna do is we're gonna run the model to predict we're gonna run the model on a test set. So if I do this, if I just run this one right here, this piece predict, what this will do is it will predict the values for the test set, right? Oops, it's okay. So anyway, basically what this did was predict. Okay, this is a warning. So keep in mind that there are different messages, and error is a problem. If there is a warning, some warnings can be ignored. This one can be ignored. So now what I'll do is I'm predicting in here. Here I'm running my model on a test set, and I'm using the model to predict the consumption, the energy consumption for the test set, right? This is what I'm doing here. And guys, what I would do is I'm going to post this script, if it will help. After the presentation, I will post this script in week 9 course content, okay? So that way you can, guys, play around. I'll post this script in the dataset. Now, so here it is. Those are my predicted values, right? What I could also do is I could produce a plot with the predicted values and actual values. So here it is. I'm going to plot my predicted and the actual. But the actual is going to be test set, right? I take the test set and I take the consumption. Sorry, that's actual, rather. Right? Because this is what I'm doing. I'm using test set to evaluate this model, right? So what I'll do is I'm going to go ahead and I'm going to do the plot. I'm going to hit run. Right. What I also want to do is I want to draw a line. I want to draw a line because see, this x-axis is a predicted and y-axis is a, well, yeah, so we have this as actual, y-axis is actual, x-axis is a predicted. What I want to do here, I want to draw a diagonal line, and I want to see how good are my predictions. The closer the points are to the diagonal line, the more accurate are the predictions. So what I'll do is, the line add line, add the line to the last plot. I'm going to go run this command. So this will show me the line. And basically the residual is going to be a difference between the point and this line. It's a distance. How far this point is from this line, right? So for every point on this line, the predicted value is equal to the actual value, right? This is a diagonal line. So basically, the closer the points are to the line, the more accurate are my predictions. So this is what you can do. This is one way. Now, what I could also show you is I can show you how to do the plots for the residual plots. There are 4 residual plots, and what you could do is, if you just run the plot, if you just run this command, right here, run, oops, I have to put a cursor here and hit run. What it will do here is, it will show me one plot at a time, and I have to keep on hitting enter, right? But I'm going to show you the trick. There is a trick to print all of this on the same page. You would need to run this command, layout, matrix. So basically what it's showing me is that I want to put 4 plots on the same page, and I want it to do 2 by 2. You'll see what I mean in a second. I hit run, and then I hit plot. See what it will do? Well, of course, this is hard to read. I'm going to do zoom, and here it is my plots. So what you can do is, here you can use the snipping tool, and you may take the screenshot with the snipping tool and put the screenshot in your assignment deliverable. So this, it's like, it saves you space also. You can take a screenshot of these 4, right? Of these 4 plots at once. So I'm going to close this out. And another thing to keep in mind is that the upper left plot, it shows the residuals. They should be randomly distributed along this line, right? So here is a line. The residuals should not form the pattern. So that means that the linear model works well for your data. And this plot is very important because there is something called Cook distance. You want to make sure that the Cook distance is not above 1. If the Cook distance is above 1 for an observation, right? That observation is an outlier. So that's how you know, right? So we went over this. Now what you need to do is you need to change it back, because what's going to happen is from now on, here it's going to do 4 plots on the same page. And since you don't want this to take effect anymore, I'm going to do this. I'm going to change it back. Okay? Now, here what I'm going to do is I'm going to build a reduced model. I want to keep only the significant variables, right? In your assignment, you need to build a second model, right? So what I'm going to do here, I'm going to use a step function. I'm going to use a step function, and what it will do is it would build a reduced model. One thing to keep in mind is that if you're using the step function, first you need to make sure that your data set does not have any missing values. Step function may not work when the data set has missing values. This is very important, right? So what I'm going to do is I'm going to hit run here. Run. Okay. Well, I got a warning, but it does not matter. It should still work. So what I did was, over here, I created the model too. And now what I could do is, oh, wait a minute. Okay. I had my cursor in the wrong command, so let me rerun this. There we go. Okay. So what it did was, this is the last iteration, right? So what it does is, on every iteration, it removes the variable with the lower AIC, right? So the lower the AIC, the least significant is this variable. It removes the one with the lowest AIC, and the iterations continue until there is no change, right? Until there is no change in the lowest AIC in here. So if I go up, it shows me the steps that it took, right? It shows me which variable was removed, because I can go ahead and I can compare. For instance, this is how my model looked like before this iteration. And here I can compare which variable was removed. Here, see, this month is missing because month has the lowest AIC value in here, right? So we remove the months. Now we have a new heat pump has the lowest AIC, right? But if I look between these two iterations, my lowest AIC has changed, right? Here I see the change. Since there was a change, I continue. My method makes the next step. Here it is. The AIC, the lowest one, changes. And here it is, it's family members. So that's the next one I'm going to remove, family members. Apparently, this is not as significant as I initially thought, right? It's a surprise. So here is my final model. What's important here is a new heat pump, total charges, year, new meters, and a bill, right? So this variable seems to be important, okay? So what now I'm going to do is I can run the summary command, and it's going to give me my new model. Yep. So that's going to give me my new coefficients, right? And it shows the significance. Notice that all of these have a 2 stars, 3 stars, and apparently new heat pump is the remaining least significant variable, right? So here you're gonna, this is your second model, right? So that's what it means to have 2 models. So does it make sense? Does it make sense? And also, in your assignment, you need to do some plots, right? So you basically can do the correlation plots. You can do the histogram. It all depends on your data, right? So you can do, it depends if your data has the categorical variables, you can do the pie charts. And the nice thing about R is that there is more than one way to do it, right? So you can do the histogram command, HIST, and here what I'll do is I'm gonna put my variable, electric bill, and then I'm gonna put this right here, and I'm gonna put, perhaps I want the bill amount, right? It's gonna bill me the histogram. What I could also do is I could add colors, right? I could do comma, colors, equals, and then here, this is a list. This is a list right here. right? And what it will do is, I specified 2 colors. It's going to cycle through the colors. Here it is. It's going to cycle. So the first bar is going to be red, the next one blue, red, blue. I can specify the colors that I want to use. And this is a vector, remember it? This is a vector, or a list. So I'm cycling through these colors, yeah. So here it is. And yes, some of you asked me about the appendix, what to include in there. And you include in there the code that you ran, right? It's not that large. See, this is my code. You're going to have a little bit more. You're going to have some plots, and you're going to have some descriptive statistics. And also make sure that the output that you include in the appendix is discussed in your actual paper, in your actual write-up, right? Make sure that all the screenshots are discussed, because if the assignment consists of set of screenshots without any explanation, assignment lacks purpose, right? Because it does not show an application of the concepts to the analyzed data set. So you want to make sure that the deliverable, the submitted work, shows a solid understanding of concepts, and the concepts are applied to the data that you're analyzing. This is very important, right? So let me see what questions we may have. Any questions, guys? It's your turn. Questions? Yes.
Yes, I have a question.
Yes.
So how do you do the linear regression model?
This is what we just did. It's a linear regression model. It's an equation of the line. Yeah. LM, yes, LM function that we just did. It builds a linear regression model. But what you would need to do is, your next step is to write down the actual model equation, right? So that's going to be, well, I'm going to, go ahead. Go ahead.
No, that was my question.
Yes, so this is what I was doing. I was running LM function to build the model right here. Is this LM? That's what I started. In here, I run the LM command right here, model, LM, right? Here is my formula. I'm specifying that I want the linear regression model to predict my energy consumption, right? Here, I want all remaining variables to be used as independent variables, as the predictors. So I want to use my other variables to predict the energy consumption. And here is the training data. What I did here, I split the data set into the training set and into the test set. Then here, I'm creating the linear regression model to predict the energy consumption. So here is my model, right? It's my initial model that I discussed right here. Here, I'm just checking the residuals. I'm just showing that you can look at the predicted values, and you can look at the coefficients. You can run the prediction on a test set. Then you can visualize predicted values versus fitted values, right? And then you can run the step command to develop the reduced version of the model. So here my reduced version of the model. And the way I would write it out is, let me write it here. And now notice this hashtag, this is the comment. So I'm gonna do this here, final model. I'm just gonna write it here for you. So what this is gonna look like is this coefficient, right? Actually, let's do this. Let's run coefficient commands, because I kind of don't like how it's written here. Let's do this coefficient. Let me see the syntax. I never remember the syntax. Okay, okay. Coefficient, and then I'm gonna do the model 2. Model 2, right? So this is, what I did was I accidentally hit the upper arrow. And when you hit the upper arrow, it's going to rerun the last command. Okay, here it is. So what I was going to do is my final model is going to be this. And I'm going to put a hashtag to make sure it's not an executable command. You're not going to have a hashtag, but I just put it because I put it in a script. So consumption is going to be equals to this intercept plus this piece right here, right? This piece times year plus this thing right here. Oops. Well, this is not what I want, but it's like this. See this here? Oops. Times bill amount and etc. Right? So those are my coefficients. Right? And you keep going. You keep going until you use all of this. So that's going to be this thing right here. Right? Plus this thing multiplied by new meter. Right? So what this actually means is that if my meter is new, right? So here, if my meter is new, then this is what we subtract, right? If my meter is new, then this is what we subtract from the consumption, and etc. Okay, you're gonna finish it. I'll leave it for you to finish. But new meter is a factor. So what we do is, if the meter is new, this is a 1, right? If new meter is new, this variable is a 1. So for each, if the meter is new, this is how much you're saving on consumption per month. Okay? So this is a reduced model, right? So what happens if I have a new record, right? If I have completely new record, how would I estimate the consumption? I would have to plug it in, the year, the bill, and the new meter. If it's a new meter, I would just plug it in. Instead of bill amount variable, I'm going to put the actual bill. Here, I'm going to check if it's a new meter, it's a 1. If it's an old meter, here is going to be a 0. 0 times this coefficient is 0, right? This is what I do here. I just plug it in. This is my reduced model. On the other hand, the initial model that I got, I would have to go through all of these variables right here. And I'm going to say, I'm going to check what my month is. If my month is September, for example, this is what I subtract from the consumption. If my month is May, this is what I subtract, and so on. If my month is August, this is what I add, right? So does it make sense? Guys, does it make sense? So basically, the whole purpose is to predict, to develop some kind of like a formula that I could use to estimate the energy consumption in this case, right? So how do I estimate the energy consumption? If I know the year, if I know the bill amount, if I know new meter, if I know if my heat pump is new, and if I have the total charges, this is what we do. I would think total charges would probably include the taxes and so on. Yeah. But they write it usually as negative. Yeah. Okay, so make sure that you guys understand it. It's a good opportunity for you to ask me questions right now. Let me know what questions you have. Ask me questions. I like questions. And I'll pause the script. Yes, go ahead and ask me. if you don't have questions, I'm going to ask you questions. Why do we divide the data into a test set and training set?
Okay. So,
Why are we doing it? Why are we dividing data in a test set? Huh? Yeah, the coefficient is correct. Yes, go ahead.
Is it because you have to show the difference is breaking the data into two different sets?
Well, because you use a training set to build the model and a test set to evaluate the model. Right. So evaluate the accuracy of your model. But we use a training set to build the model, test set to evaluate the accuracy of the model. Now the coefficients, yes, the coefficients are going to determine the estimated consumption. Yeah. Because basically coefficient is a slope. Each coefficient is a slope, right? Because if you may or may not remember from the algebra, I believe it's algebra class, where you have a line, and the line is defined as the sum of the intercept, y equals intercept plus the slope times x, right? So this is what happens when you have a plane, when you have a two-dimension. The equation of a line is the coefficient plus slope times x, right? Here, it's similar, except it's no longer a plane. You have multiple dimensions. It's a hyperplane. It's a similar idea. An intercept plus slope for each variable, right, multiplied by the variable itself. So this is a slope. So remember this. Y equals b plus ax, I believe. Well, it does not matter how you use the letters, but here is a y-intercept. It's a value of the dependent variable when x equals 0, right? This is the intercept. So if I'm going to draw my line, it's a point on the y-axis that the line is going to cross. A is a slope. So what it means is that if I increase my x value by 1, the slope is the amount by which y is going to increase. So increasing the x by 1, slope is an increase in the y value. Similar here. So if I increase the bill by $1, yeah. Oh, your microphone does not seem to work. Oh, I see. Because I don't see the chat window. Let me see if I see the chat window. Okay, chat. Let me open the chat window. Here it is. Okay, Oh, I ran the step function only once. I ran it just once. Yeah. I ran the step function once, but it loops through several iterations. That's what it does. Here, the output shows the iterations of the step function. I executed just once. Here are the iterations. Here it is. I just ran it once. Yep, here. It once. Right here. But what it does is it prints me every step. So you probably don't need to... okay, great. Yeah, but in your deliverable, you probably may not need to show every step here, but you may want to show the last step, and you may want to compare which variables were eliminated, right? So you're going to be you guys working on different data sets, right? Some of you might be estimating the price of the house. Some of you might be estimating the body fat percentage, right? So these data sets are very interesting. All right, and now what I wanted to show you guys, this is going to help you later on. So in your classroom, notice that you have the course content, and everything in the course content, it has a lot of helpful resources. So if you go to the content, right, here it's all organized week by week. So in case you may have missed it, this is very important. So here is my week 8. right? It shows me different links it shows you different links for the videos, and it's broken down by topics. So you have the lesson guides, right? And it has a lot of other resources. So make sure that you see the content, because some resources posted in the course content might be very helpful to you. They may help you with assignments, and there could be something additional that you can explore later on. See, this is a cheat sheet for the R commands, and this is our studio tips. It shows you different menus, right? So, and here are the useful videos. Okay, let me see the chat. And where can I find the slides? Oh, the slides for original WebEx, I believe they were posted somewhere in the news. Let me see, something's going on. Okay, I believe they were posted on a news page. Click course home, and then those are the updates. And I believe they may have been posted. If they're not, then if they're not, then I'm going to upload them. Let me see. There's assignment 4. I click show more items, right? I click show more, and trying to find them. You have to scroll down, and you'll find them. Right. They're right here. Slides, introduction to, right here. Right? So you would need to click on view more, news. And the slides are in here, PowerPoint slides. Right. But if you have questions about the slides, yeah, feel free to ask me. Because my goal is to help. Right. So, and another thing that I would strongly recommend, actually going forward as well, for your discussions, at least try to post the first initial post by Thursday. Why? Because one way to learn in online classroom is to learn it through discussions from your classmates. Just imagine it's as if you were sitting in a class and discussing the topic. So it's supposed to be interactive. So if you post it by Thursday, it gives your class members an opportunity to respond to you. So this is what I recommend. I would recommend doing a first initial post by Thursday and then responding to your classmates, because it will really help you learn, right? Because the whole purpose is it's similar to when we are having a meeting and sitting in a classroom. I give you a question, and I get you guys responding and asking follow-up questions and so on. So this is equivalent to classroom interaction, right? So make sure you're paying attention to the content. Another thing is you can set up some notifications. You can perhaps set an option for the system to email yourself when your grade is posted, perhaps, or when the news items is posted. And another thing that you could also do is you can use the bookmarks here, like something in the content, and you can put a bookmark, something like that. Suppose the course has a bunch of content, and you worry about getting lost. Oh, where did I see this? Where did I see that? So what you can do is you can create a bookmark here. So isn't that nice? It's really nice, right? So, and another important thing that I wanted to point out, in the course resources, you have writing resources. Yeah. Oh, goodness feed. Excellent question. This is basically asking how good is my model. All right? So you want to tell how accurate is my prediction. That's what basically it means. It's an open-ended question. How good is your model? Do you think it accurately estimates, in my case it was energy consumption, how good it is, right? So you want to look at the residuals. You want to look at what we showed, the difference between actual versus observed values, right? So you want to look at this stuff, and also you want to look at the residual plots, as I was showing you. As I was showing you right here. What was this? I was showing you the residual plots. Oops. See this? You can use this to navigate between the plots right here. And I'm going to go zoom. So basically, you want to make sure that the numbers along this line are randomly distributed, right? And here is a normal QQ plot. So you want to look at those graphs right here. And you want to make sure that the Cook distance is below 1, which I believe it is for most of the observations. Here, you want to make sure that the points, they don't form the patterns. Yeah, and you want to make sure that same thing here. 5% significance level. Oh, okay. It's right here. It's for your p-values in here. So it means that the variable right here is significant if this p-value over here is below 0.05. Yes. So that's what it means. It tells me which coefficient is significant. And the coefficient is significant if p-value is below 0.005. Then it's a triple dot. It's a triple dot right here. These two. Bill amount, and if it's a new meter. These two guys right here have a triple dot. Right? So what it means is these two variables are very, very significant because my p-value is below 0.005 here, right? And this is a 95 confidence interval, 95% confidence interval. That's what it is. So we are 95% confident, in other words, right? The amount, yeah. So that's basically what it is. It shows me what p-value needs to be.
95%?
It's a confidence interval, 95% confidence interval. Yeah, because 5%, where does the 5% come from? It's because it's a 95% confidence interval. That's what it is. So you have a...
From that decimal right there?
0.00. If this guy right here is below 0.005, right, which is here, then it means this variable is significant. It's a significant predictor of the energy consumption. This shows me how significant the predictor is. Right here, bill amount and new meter are very, very significant predictors because the p-value is below 0.005. Yeah. So this is very, very significant, these two guys right here. And here it just actually shows me. It just actually breaks it down for me. Yeah. Oh, it even goes 001. Yeah. So here I have 3 stars. This is 3 stars. This one is 2 stars. So if it's below 0.005, right, I've got 2 stars. And if it's below 0.001, I've got 3 stars. See this? Oh, dependent. I'm sorry, what's your questions? Let me look at this. 5 significance. Oh, okay. It shows me that my independent variable, this independent variable, bill amount, is a very important, is a significant predictor of the energy consumption. So when I predict how much energy was consumed, bill amount and the new meter are very significant predictors. Dependent variable is a variable that I want to predict. Independent variables are the variables that I'm using to predict. The independent variables are predictors, right? So in this case, year, bill amount, if I have a new meter, and if I have a new heat pump, right? If I have a total charge, these variables predict my energy consumption. They're predictors. Now, how important is a predictor? Is it really important? Is it really significant? And here, the triple dot right? 5% significant. It shows me that this variable is very, very significant predictor. It is important. New meter, whether my meter new or not, it affects the energy consumption. It's a very important predictor. That's what it means, right? So if I ask you what are the important predictors of energy consumption, you're going to say wheel amount, and new meter, because the p-value is really low in here, right? So this is what it is. Make sure that you understand this part. This is important, right?
So again, the independent variable is the predictor?
Yes. Independent variable is a variable that we use to predict, and dependent variable is a variable that we predict. Yes, but in the books, you can use the terms interchangeably. They also call the dependent variable as a target variable. It's another terminology. And the independent variables are also called the predictors. You may find these terms interchangeably in the data mining books, right? So this is something to keep in mind, that some terminology are used as synonyms. So in this case, yeah, again, here this. This is a data set, and I removed the unique identifier. So if you see unique identifier, you can remove it right away. And I'm using all of these variables initially as predictors. And my model threw away some of them because it believes that some of them, there is something called collinear variable, when one variable can be derived from another variable, right? In this case is a cooling degree days and the average temperature. Those variables are collinear. So in other words, knowing the average temperature, I can compute my cooling degree days. I can compute my heating degree days. Because basically the way it's computed is that they take the average temperature in a day, and it's compared with the 65 degrees. And the number of cooling days is the number of degrees that my average temperature is above the 65 degree mark. And the heating days is the number of degrees that my average temperature is below 65 degrees. It goes by day, basically. So knowing the average temperature, I can determine the cooling degree days. So that's why you see the NAs in here. This eliminates the collinear variables. Collinear variables is basically when I know one, I can determine the other. So these three guys are collinear. Huh? So the model eliminated them for me. This is called multicollinearity. So knowing the heating degree days, I can determine my average temperature, right? So that's basically what it is. These three is eliminated immediately. I eliminated the unique identifier. Then what I did was I ran the step function because I want to keep only the most significant variables. I want to build a reduced model, and then I want to compare my reduced model with the initial model, right? That's what you're asked to do in the assignment. And you also asked to do some plots, so you can do the histograms, and remember, histogram is for the continuous variable, right? There are two types of variables. There is a factor. Factor variable has discrete values, and the values predefined ahead of time, like months. We have 12 months. Continuous variables, they don't have a set of fixed values. For example, in this data set, the charge is continuous. The energy consumption is continuous, right? Because the charge, it can be $100, it can be $1,000. There is no set of predefined values. And in the data set that you're using for the homework, body fat percentage is going to be continuous. House price value is going to be continuous. area burned by the fire is going to be continuous, right? So this is something to keep in mind too when you're doing your analysis. Yep. Questions? Yes. Oh, great. I'm great I could help. And what we will do is we will pause the recording. Let me stop sharing for a second and let's see. Okay, excellent. So I can see that it's recording. That's great. I'm gonna share again. Okay, so that's good to know. Basically what we'll do is we will pause the recording. When the recording is generated on a server, we're gonna post the file. So that way you have this, you have a copy and you can reference to it later. But if you are able, for the last lecture, I believe you got a copy of the actual file itself, and you can open it with WebEx recording player. Yeah. You can just save the file and open it with WebEx recording player. Yeah. So let me see. Do we have more questions? So everybody is confident that you can do the project and you can do a great job, right?
One more question.
Sure.
Do we enter in, I guess, in the upper left-hand corner where you enter in the commands, do we have to enter that in, or does our
here, this is a script. This is a script that I wrote. This is a script. There is more than one way to do it. I can type the command in the console, but since I don't want to waste your time while I'm typing, just to save time, I typed it before the session. And then what I did was I just ran the script. I typed the commands ahead of time, and then I ran the script. That's what I did. Yeah. So this is what I did, basically. I typed this, and I'm going to pause the script. Yeah. Go ahead.
Okay. So we actually have to do that?
There is more than one way to do it. I would recommend typing the script because when you come back next time, you can just rerun this. You don't have to retype the commands. I recommend this. And the way to do this, you go File, New File, R Script, right? You do this, and it will create a new document here. And then what you do is you save all the commands here. Like, for example, suppose that I run this summary, and I put electric bill, right? So I run this command, and I'm happy with this, right? What I could do is I can copy and paste my command here, or I can just go to history. I can highlight this command, and I can do to source, right? To source here, right? So it's gonna add the command to my script, and then I have to save the script. I need to make sure that I save it, right? Or I go File, Save As, right? You want to save this. And then when you come back next time, you just go File, Open. You open your file. Because some exercises are long. Sometimes you cannot do it in one sitting. But if you restart the RStudio, all work that you did in the last session could be gone. You need to save the script. And I'm showing you how to do this. Well, so everybody does differently, but this is a recommended approach, is to save a script.
Okay. So if I go to the history thing, it will give me all the programs that I have to run for this project?
No, history is going to give you the command that you ran. History is a history of the command. When you run the command, it's going to add this to this history. It's a log, basically. So that way I can go back and rerun. And also what it does, if I hit the upper arrow on my keyboard, upper arrow key, it displays the previous commands. Because what if I need to rerun it, right? I don't want to type it again. So it saves me time.
Okay.
Right?
Okay.
Because I'm showing how to do this, how to use the study time, how to use the time effectively, right?
Okay.
You don't want to be retyping it multiple times, right?
Okay. I just want to know, like, what I have to do to follow the requirements for the assignment.
You need to pick the data set, and then you need to define the purpose of your study, right? What data you're analyzing, and what is your target, which variables you're using as predictors.
Okay.
So this is right here in the, let me see. Here are the guidelines. Let me close this here. Okay. So here are the assignment guidelines, and you need to select the data set, and you have to provide a brief description. What data is it? What variable you're predicting? Here you have to do you need to do some of the summary. You have to run some statistics, right? And you have to set the working directory. Actually, you set the working directory before you. Oh, okay. Here it is. You examine it first. That means you're looking at it in Excel. That's what it means. Here you're setting the working directory. You're loading the data. You're doing exploratory data analysis like summary commands and so on. Then you do the splitting the data into training and test set. You're building the model, exactly what I was doing, something similar. I did something similar today. I followed these steps. So I'm going to give you my code, but you'll need to write your code for your data. Alternative models, that's what I did. I ran a step function to come up with this. And this is a data visualization. And here, just showing you the format and how it's going to be graded.
Okay.
This is basically rubric. It means how the instructor will grade an assignment. That's what it means. It's a points breakdown, basically. So, yeah. So, the key to success is to utilize the resources in the classroom. When you've got the writing resources, make sure if you're using any outside sources, you need to cite them, right? It's very important. Yeah. So does it address the question?
Yes.
Great. I'm great that I could help you. Anyone else? It's an opportunity to ask questions. And what's going to happen is I'm going to be watching the discussions over the weekend. So if you have a question, go ahead and post it, and I will respond. Okay?
Thanks, Jelena.
You're welcome.
Thank you. And if we have, we can just email you, right?
Yes, you email, and you also post the question in the classroom, because your classmates may have the same questions. The questions benefit not only you, but the whole class, because we may have the same question. And sometimes, if I have a question, I can go look, nice, my question already answered in the discussion. So that's another tip for the online class. You post your questions in discussion. It helps the class.
Okay.
Right?
Thank you.
You're welcome. And I'm going to stop the recording. I stopped sharing, and now I'm going to stop the recording. Meeting. I have to find it. find where it is.